So the general idea, if you have a function f that's bigger than g, then if the bigger integral converges, then the smaller one has to also converge. Also, if the smaller one diverges, then the bigger one also has to diverge. That's just the general idea. So looking at this problem here, we want to know if this integral converges or diverges. And the idea is to use the comparison test. So here's what we can do. I claim that this numerator, 2 plus sine, is greater than 1. And here is why. Think of the number sine x. What is the biggest and smallest that sine x could possibly be? Recall the graph of sine, how that the biggest the sine could be is 1, and the smallest that sine could be is -1. So at most, the biggest that this could be is 1. And when this is 1, this whole thing is 3. What is the smallest that sine could be? The smallest value that sine can take is -1. And if this is -1, then 2 minus 1 is 1. So for that reason, this whole thing is greater than or equal to 1. Now, why exactly do we make this comparison? Because what we can do now is we can divide both sides by this here. So just real quick, we know that 3 is greater than 2. However, if I divide both sides of this inequality by a number that's negative, then the direction of this would switch. If I divide both sides of this inequality by a quantity that's bigger than 0, then this inequality stays exactly as it is currently facing. This quantity that we're going to divide by is going to be 1 or bigger because this integral begins at 4. And if you plug 4 in there, it's 4 minus 3, which is 1. Square root of 1 is 1. So because we are dividing by a quantity that is positive, then the inequality does not change its direction. It's respected. So this is the original. This is what we're going to compare it with. So we have established that this quantity is smaller than this quantity. And so let's take the integral of the smaller piece. Is to completely forget about everything above. Let's just knock out this problem here. So I let u equal the stuff there. Du would be dx. I rewrote this in terms of u's. And temporarily, I'll throw away these numbers until I bring the x's back. So square root u is the same as u to the 1/2. But if you bring it to the top, it becomes -1/2. And now we can actually just apply that property of taking an antiderivative, where you add 1 to the power and then divide by the new power. So I did just that. I added 1 to this, and I divided by that new exponent. So -1/2 plus 1, that's just 1/2, 1/2. Dividing by 1/2 is the same as multiplying by 2. Exponent of 1/2 is just the square root. U gets turned back into x's, x minus 3. And once you have x's back in, we can evaluate from 4 to infinity. So I plugged in infinity, minus, then I plugged in 4. But notice the problem, I have a square root with an infinite number. And so for that reason, because there's an infinity, we have a case where this integral diverges. And remember that this guy here, it was the smaller one. So if the smaller one diverges, then the bigger one is guaranteed to also diverge by the comparison test. So for that reason, the final answer is that this integral diverges. And notice that the function that we compared it with looked a lot like it. It had some similar pieces, but a couple of the pieces were stripped away, and we had something simpler to compare it with.